Hi folks, today we're going to give a bit more of a mathematical treatment to something that we looked at last time. You remember this little simulation from last time. It showed some kind of material. It starts off fairly cool. We're adding heat to it all the way through this experiment. So as we add heat, the particles start to vibrate more and more. Then we reach a certain point where even though we're always adding heat to this, the temperature stops increasing for a while, and then the particles start to break apart. They start to lose their bonds holding them together. That's because the energy from the heating stops going into increasing the temperature and goes into breaking apart the bonds in this material. So it goes from being solid to being a liquid. Now we call that amount of energy the latent heat. Latent means hidden or concealed. So even though during this period here we are adding heat, the way that we normally measure or get an idea of how much heat there is in something is to measure its temperature. But while we are adding energy to this material, the temperature stops increasing. So it's difficult to tell exactly how much energy we're adding. You should remember from key stage 3 that although heat and temperature are related, they are different things. For instance, if we have a little cup of water and it's at 50 degrees Celsius, and I have a massive bathtub of water and it's also at 50 degrees Celsius, they are at the same temperature, because we can stick a thermometer in either of them and it will read the same. But the bathtub has a lot more heat because it has more energy. So heat is always relating to energy, whereas temperature is talking about your degrees Celsius. It's another example, a little bit like mass and weight, where we talk differently in science lessons compared to the way that we talk in the real world. You will use the word heat to mean temperature in the real world. So the amount of energy that it requires, that this material requires to change its state from a solid to a liquid, is called the latent heat of fusion. We refer to the whole thing in general, whether it's melting or evaporating or condensing or freezing, as latent heat. So that's a general term for all of it. When it's melting or freezing, it's the latent heat of fusion, and when it's evaporating or condensing, it's the latent heat of vaporization. We are going to look at an equation for this, which uses the term specific latent heat. That's because we're really interested in how much energy it requires for a certain amount of stuff. If we're just talking about latent heat, we could be talking about tons and tons or just a few milligrams. We're not sure how much it is. If we talk about specific latent heat, we're always talking about the amount of energy it requires to change the state of 1 kilogram of stuff. That's helpful because it means that we can have a constant. If we've got the amount of energy it requires to change the state of 1 kilogram of stuff, that's always going to be the same whether you've got copper that was mined in Australia and you've got 10 tons of it, or it's a little piece of copper that you found in a coin that's been buried since Roman times. So in the materials for this, my homework assignment, you should have this. You can find it in a number of different ways. There's a Word document, there's a PDF document. However you're finding it most useful and easiest to get access to it. So if you want to fill it out online, that's fine. If you want to print it and then take a picture, that's fine as well. But you need to complete this table and then submit it some way. So I'm going to work through this question here, which has already got a few notes for it, and I'm going to work through this question here, and then The other two questions you can do yourself, and then do these questions down here. So the very first one, calculate the specific latent heat of fusion if. So the equation relating energy, mass, and specific latent heat is just energy equals mass multiplied by specific latent heat. If you're very observant, you might have noticed that there's a little bit of a mistake here. Mass is not measured in meters, it is measured in kilograms. Quite often with these questions you will get a temperature measurement as well. If you look at this equation, there's no temperature in it, so this number here is a little bit of a red herring. You don't add it or multiply it or divide it or anything. That's kind of just to tell you that, so what we're doing in this one, we're changing solid oxygen into liquid oxygen, which happens at a very, very cold temperature. That's why oxygen exists as a gas at room temperature. That's just so that you know all of this energy is only going into changing its state. All of that 28,000 joules is only going into changing it from a solid to a liquid. So none of that energy is going into changing its temperature. That's how we know all of that energy is latent heat. So I'm not going to follow every single step here because it's already written out, but writing down the equation is always useful. This is one of the equations that you get on your data sheet, so you don't need to completely memorize it, but the more familiar you are with the equation, the easier you'll find it to use. So the question tells us the amount of energy, 28,000 joules, and it's asking us for the specific latent heat of fusion. So we're also given the mass, 2 kilograms, so it equals 2 kilograms times our specific latent heat. Now, you'll do a lot more rearranging of equations in maths, but it's a very important skill for science, particularly physics as well. So however you like to rearrange equations, whether you think about it as the 2 drops down underneath, or if you like to think about it as divide both sides of the equation, so you've got the equals in the middle, so this is your left hand side of the equation and this is your right hand side. You could divide both sides by 2, so that cancels, and then 28,000 divided by 2 is just going to be equal to your specific latent heat. However you like to do it, however you like to arrange and rearrange your equations, do it step by step. Make sure you do your working and take an individual line each time so that you can see what's going on. That's the whole point of questions being laid out like this, so that you get good working habits. Anyway, 28,000, then I'm going to divide both sides by 2, so 2 divided by 2 is just 1, and 28,000 divided by 2 is 14,000 equals our specific latent heat of fusion. There's one thing that is missing from this answer down here, and that's a unit, and the unit would be joules per kilogram. Okay. Next one then. So calculate specific latent heat of fusion if 183,600 joules is supplied to turn 3.4 kilograms of solid sulfur into a liquid at 115 degrees. So that's going to be our specific latent heat that we are being asked to find. So just like last time, I'm going to divide both sides by 3.4 in this case, because I want the specific latent heat on its own on the right. So that's going to cancel out. I've got to divide this side by 3.4 as well. Don't be too proud to use a calculator, folks. You must be watching this on a computer or a phone or something like that, so you've definitely got access to a calculator, even if you need to use Google. So 183,600 divided by 3.4 equals 54,000 joules per kilogram. Okay. So there are two more questions that take you through it step by step. You be careful with this one. That says 600 grams. You always work with mass in kilograms, so you'll need to do a little conversion there. And then there are 4 more questions down here. Again, be careful. We've got 400 grams, 250 grams, 30 grams. And this one here is in kilojoules. So complete the table showing you working in each stage, and then complete these questions and remember to show your working, and then submit to show my homework.